Okay, anybody does not have a partner? Let's see.
Let's move you over to Emma, so Emma is not here. So we have So Emma, Kate, can you raise your hand? Karen's on the phone, we'll hang out with you. Okay.
So looks like we started already, am I right?
Yeah.
Yeah, all right, here we go. You know what, Brandon, I like that desk on you. So why don't you sit there? Okay. Look, you can say hi to James.
Hi, James.
So let's just kind of recap really quickly. We wrote it all out. You should have it in your notes already. So if the degree is even, how does it open? What are the end behaviors?
Oh, same way.
Same way, either up or they both have to be down. Okay. If it's odd, what's happening? Different ways, opposite ways. Okay. So we talked about this thing called the x-intercept, which is the same exact as a root. Or sometimes I will use what word? Zeros. Okay. You need to know that I'm asking for the same thing. Then the next one says, are any of them double? Okay. Double means 2, right? Okay. Now, it could be higher than 2, like 4, like 6, like 8, okay? So if you have an even multiplicity, the multiplicity is really fancy. Okay? Multiplicity just means multiple of its own thing. Okay, so again, multiplicity just means multiple of its own thing. So if you have x squared, that is a multiplicity of how much? 2, because it's really x times x, right? There's 2 of its same thing. Would you guys agree? So that's what I mean by double or even multiplicity. So again, multiplicity is the same thing. It's all multiplying itself, right? Or, so if it's even multiplicity or double, then by definition, it touches the x-axis. Okay, so let me go up a little bit and talk about when it's even. And I believe we kind of started. Can you see this graph over here? How many zeros do we have? 3. Are any of them touching just the x-axis?
Yeah.
Which one? Not crosses, just touches. The last one. So that's the difference. So would you agree this last one, x is at 3? Yes or no? Okay. So that is right here, 3. So when I write it in a quantity, x, let me use a different pen, minus 3 is what I want to write. Yes or no? When you put it back in the factor form, would you agree the factor form would be x minus 3? Right? So when I say, well, solve, I mean I take this and it goes to 0, x comes out to be what? Right. Now, but because it touches, right, out here should have a degree of what? Even, which is squared. Okay? If I really wanted to, isn't 4 also an even number? Or 6 or 8 or 100? Okay? So this is what it's talking about when it says doubles or even multiplicity. An even multiplicity, meaning that, hey, out here, when I write it in the factor form, oops, I meant to say a square. In the factor form, I should have that. Okay? Now let's talk about the one in the middle. Let's call it as a negative half. Does it cross the x-axis or does it touches? Cross. So what kind of multiplicity should it have? Odd number or even number? Odd. Normally the nicest odd number is what?
Uno.
Uno. Okay. So if I were to write it, so let's say this is a negative half. So would you agree if I were to put it back, it would look like this in the factor form? Yes or no? Yeah. Okay, so let's check it out. So right now, what value is this? Negative 4. See that? At negative 4, is it crossing or touching the x-axis? Crossing. So when I write it back, what kind of multiplicity should it get? It crosses odd, right? So let me ask you this. How many degrees is this? Right, you're all together. What's the total degree?
5.
What degree does this factor have? 1. What degree does this have? So total right now, how many? 2. What degree does this have? 2. Degree is 2 more, isn't it? So total, this function has how many degrees? 4. Does it match with the graph? Are the end behavior going the same way? Yeah. So that's why we need to be mindful of when it touches and when it passes. Okay. Okay, so that's what we mean by odd and even multiplicity. So we're going to use it. Now you are going to graph it by hand. That means no calculator on tonight's homework, okay? One of my students said, well, why do you teach us how to use a calculator? Well, so that we can check it. We can graph by hand and then plug in and be like, the calculator looks good, I look good, I should be right. Okay. All right, let's go. Numbers 1 to 5, that's all we have to accomplish today. Sketch a graph for each function based on zeros and end behavior only. So, based on zeros, how do we get the zeros? You know, to find the zeros, that's pretty much saying what? How do we find the zeros? Yeah, that's why it's called zeros, because we take the y and we make it 0. Okay, how do we solve for x from here? Do we multiply back out? Do we multiply back out? Remember, we're solving for the 0. So what do we do? Emma P?
Is it just set 0 to x equals, wait, 0 equals x minus 5 and 0 equals x plus 9?
Yeah, aren't these already factors? So can I just take each factor and set it equal to 0? Okay, so x minus 5 equals to 0. So Hannah, where is your first x-intercept at? Good. X plus 9 equals to 0. So where is your next x-intercept at, Chance? Good. So let's plug those in, guys. Do 2 x-intercept. One's positive 5, 2, 4, 5, and one's negative 9. Put 2 x-intercepts in. Next, we will need to determine the end behavior. Okay, end behavior will require you to tell me the degree of the function. What is the degree of the function? What is the degree of the entire function? Baron? 2. How do you know, hon? How did you get 2? If I multiply this all out, what is the highest degree that you can get from the whole thing? X squared. So that is Baron's right. It's a degree of 2. The end behavior also is determined by the a value in the front. What's the leading coefficient in the front? What's in front of x squared? If I were to fully that all out, 1. You guys agree with that value? Okay. So if I would multiply that all out, it's going to be 1. If the degree is 2, is that an even degree or odd degree? Even. So should the end behavior go both the same ways? In this case, they both should be going up or down? Up, because a is positive. Can you guys see that? So now it goes like that. I'm gonna hold on tight so we can ask more questions. Would you agree that end behavior goes like that? Now we need to decide in the middle, in between the 2 x-intercepts. At each x-intercept, is it an even multiplicity or an odd multiplicity?
Odd.
Odd, right? Because this whole parentheses has the power of what outside? And this whole parentheses has what power outside? So they're both odd. If they're both odd, I'm going to make a curve here. If they're both odd, class, should I go like that? Or should I go down? Down, because it has to cross. So both sides has to cross, yes or no? And then guess what? You just connect them because I'm just sketching based on the end behavior and the zeros. Any question on just the first one? We are using odd multiplicity, even multiplicity, and behavior, and zeros.
What is this called, like solving by what?
This is graphing. Graphing using just the zeros and behavior.
Zeros and behavior.
Yeah, so we're just sketching out, like, what can it look like? It's not an exact graph. Okay. All right, 2. How do we sketch 2 out? What did we start with? Find all the zeros. Yep, that would be the easiest. Zeros mean, what do you do to find all the zeros? Take the y and turn that into a 0. Okay, now what? What do you do next to find all of my x-intercepts? Huh? Yeah, it's already factored. So can I take each factor and set it equals to 0? Yep, let's do it. Okay, how many factors do you guys have here? Okay, so the first one is x equals to 0. Do I need to solve any more for that? Nope, it's already at 0. Plotted out at 0. Bam. Okay. Next, whoa, x minus 1 to the power of 2. What kind of multiplicity is that? X minus 1 to the power of 2. What kind of multiplicity is that? Even or odd multiplicity? Even. So at this location, is your curve going to cross the x-intercept or just touches? It's going to just touch. That means it's going to bounce off. Okay. So I'm going to solve for it. Do I need to solve it twice or once is good? Once is good. Okay, it's the same location. So the next one is x is at 1. But I'm going to write out even what? Even multiplicity. It has a significant, right? Because I later need to not cross. I need to just touch the x-axis. Then the last one, x plus 8 equals to 0. X is at negative 8. So that's my last x-intercept. Okay, any question of just kind of solving for the x-intercepts? Next, I need to determine the end behavior, and to do that, I also need to find the degree. What is the degree of this entire function? What's the degree? Baron? You were saying 4? Anyone disagree with Baron? 3?
Wait,
If I multiply them all out,
4.
multiply them all out,
It would be 4.
what's the highest power? 4. Because when you multiply, do you add that powers? Yeah. So what power does this term have? 1. What power, carefully, does this one have? 2. That's already 3, right? And this has 1 more. So the degree is what? 4. Now I need to find an a value because that would tell me if it opens up or opens down. What's the a value? When you multiply them all out, what is the leading coefficient in front of x to the 4th? 1. So how does it open? Up or down? Up. Okay, so up. So on the ends, I just have to go up, arrow, and up. Look at that. I'm almost done. Now, our next task is to decide. At negative 8, should I bounce it or should I cross? Cross is right. So I cross. At 0, what do you do? Okay, so remember you're going to connect that with a 0, right? Like that. At 0, do I cross or do I bounce? At 0. Yeah, because doesn't that have a multiplicity of what? Odd or even? Odd. There's only one of them. So do I cross or bounce? Cross. Okay, so I'm going to cross. So far, so good? At 1, do I go down or do I bounce? Bounce. Why bounce? Because it is even. So what's happening is, guys, be very careful. This has that low guy in there. You guys see that? Okay. So how many turning points do you see? How many turning points? Is it 2 or 3? 3, right? There are 3 total? With that, is that applicable to our degree of 4? Yeah, remember, it can have at most, right? At most 3. It doesn't have to have all 3, but it can have at most 3. Any question how to sketch that out? Do you guys understand how important the odd and even multiplicity is? Okay. Last one. I mean, not last one, sorry, number 3. Similarly, what do you start with? Set it equal to 0, because we want to find the zeros. 0 equals negative in the front, x plus 2 times a quantity, x plus 7 times a quantity, x minus 5. Is it already factored for you? Yeah, so take each factor and just set equal to 0. Well, what number is that in the front? Negative 1. Is it ever equal to 0? No, you ignore it, okay? Then we have 3 more zeros to solve. Can I just write x equals to negative 2 straight up? X, what's the next 0? And last one? Great, let's plot those, okay? Negative 2 is right here. Negative 7 is right here. 5, 2, 4, 5 is right there. What do we do next? End behavior, right? To get the end behavior, what do you guys want to do? How do we decide? How does it behave? I need a degree. What is the degree of this entire polynomial? 3. You are correct. It is 3. Anyone does not know or see why it is 3? Okay. I need an a value. Negative 1. Yep, there's a negative 1 in the front. Whoa. And the negative 1 is a reflection over the x-axis, right? Okay. Let me remind you of a parent function. Remember y equals x to the third is the parent function? Remember this? And we talked about it looking like a lazy s, like that. If you have a negative 1 in the front, it's a reflection over the x-axis. So whatever's on the top, it should not be on the, whatever's on the bottom, it should be on the top. So can you see the end behavior is changing? Okay. So for our sketch, when x approaches a negative infinity, what is y approaching? Infinity, right? Remember, look, this is the parent. So we want to, when x approaches negative infinity, y is approaching infinity. So this should go like that. The end behavior, when x approaches positive infinity, what should y approach? Negative infinity. So there you go. Okay. Next. At negative 7, should I bounce or should I cross? Cross, right? So I'm going to cross. Okay. At negative 2, should I bounce or should I cross? Cross. So I'm going to go whoop. So far, so good? And then at positive 5, should I bounce off of that or should I cross again? Cross. So this one go whoop. And that's connecting all of that together. Make it nice and smooth. Don't make it choppy. Okay, so later in pre-calc, you're going to learn how to get these min and max value, but right now we're just going to sketch it out.
Wait, what makes it bounce again?
What makes it bounce, guys? When you have this right here, Brandon, let me get a different color highlighter. Can you see right here in the previous example, this right there has a degree of 2? That's an even multiplicity. So at positive 1, you see that right there? Notice how it's bouncing right there. That's all even multiplicity will make it bounce. Last 2. Okay. Y equals negative 2 times x to the fourth plus 3x to the third plus 20x to the second. Oh, wait, what? How do we find all the zeros? What do we do? You have to factor, yep. So 0 equals, and then take out a negative 2. If you see a negative in the front, take out a negative 2x squared. Okay. Oh, I lied, just negative x squared. Ooh, good eye. Okay.
Why do you have to negative x squared? Why can't you just do x?
The reason is when you factor a trinomial, many of us, not all of us, do better with a positive trinomial leading coefficient. Does that make sense? You don't have to per se. You're still going to get the same zeros. Okay. That's okay. Take out negative x squared. Then be mindful. What are you left with? I took out positive 2x squared. And then the next one, minus 3x. And the last one, minus 20. Yeah. And the reason I say to take out negative is a lot of us do better if this right there is positive. Is that the end of factoring? No. What do you do now? You got how many terms left? Go ahead and factor that out. I'm not going to factor that for you. You need to know how to factor that. And I'm just going to call you to give me your remaining factors. All right, you and your partner, work it out. Talk it out together. Like, hey, let's do this together. So, factor it all out. Compare answers with one another. If you need space, maybe the back is blank. Maybe you came to the back. Need more work. Factor it completely. I will be asking you to give me the final factors, okay? Because we have quiz on this a bunch of times. By now, you guys are experts of factoring. Did you guys come up with the factors yet? All right, Joe, what are your two factors?
4 and negative 5.
No, just give me the two factors.
Okay, 2x plus 5.
2x plus 5.
And x minus 4.
X minus 4. Someone confirm those for me? Yeah, good. Perfect. Thank you. All right, so Joe already went ahead and solved with a 0. That's okay. We're going to take it. So we're going to take negative x squared equal to 0, 2x plus 5 equals to 0, and x minus 4 equals to 0. Guys, if you have a negative x squared equals to 0, what must x be? 0. Is that one of the zeros? Is that okay to have 0 for an x in a set? Yeah, don't be scared of zeros, okay? Then the next one, 2x equals negative 5. X is at negative 5 over 2. That's the second 0. Then the last 0 is when x is at where? 4. Let's plot those, okay? 0 is one of it. Negative 5 divided by 2 is exactly where? 2.5. 2.5 on the negative side, y'all. Okay. And the positive 4. 2 and 4. Okay. Now we need to determine the end behavior. What is the degree? What's the degree? What's 4? Because isn't the highest power, highest exponent of the whole thing? Okay, so your degree is, I'm going to write it on the right here, because at the bottom, I think you guys are having a hard time. So degree is 4. an a value. What's your a value here? Negative, but not negative 1, negative what? 2. Okay. The 2 is going to be a vertical stretch, so it's going to be a little bit smaller than normal. But the negative still tells me, how does it open? Up or down? Down, right? The negative will always tell you, Brooke. Yeah, negative 2 for A. Brooke, A is always the number in the very, very front. Okay, so you have, like, we write ax squared plus bx plus c. Well, remember, the a value is when it's in standard form. You multiply it all out. Okay, good question. You guys see what she said? Okay, the a value is when you multiply it all out, and the number is that's in front of the highest power. All right, so we know it opens down. So as x approaches negative infinity, what's y approaching? It opens how? Down, right? So as x approaches negative infinity, what's y approaching? Good. X is approaching positive infinity, what's y approaching? Also negative infinity. Remember, even power, oops, they have to go the same way. So that is that, and that is that. Your x-intercept at negative 2.5. Uh-huh.
Wait, should they be going opposite ways?
No, because what degree is this?
Oh, so that's not the degree.
Yes, always. Okay. At negative 2.5, do we bounce or do we cross? We will cross. At 0, cautiously bounce. Why bounce, Brooke? Yes, the power for 0 is even. Can you guys see that? So I'm not going to cross it. I will cautiously graph it so it looks like it's bouncing. Okay, so we knew it's going to cross, and it looks like that right now. Would you agree? Yeah. Then at 4, do I bounce it again, or do I cross it? I cross it and make it nice and smooth for the whole function, okay? Do we know when to bounce now? Okay. Number 5, last example of today. What do you do? I bounce on what, huh? I did. I bounce on 0. On number 5, what do you do first? Factor by grouping, because there's 4 of them, okay? So find the zeros. Go ahead and factor. 0. So 0 equals x to the third plus 2x to the second minus 25x minus 50. Okay, I'm going to give you a minute to factor that out. Please talk to one another. Say, hey, I'm stuck here. What'd you do? I got this. What did you get? And if you can factor it, you can even go all the way to find the zeros. Plot it. Go all the way. See how far you can go.
Yeah. Yeah.
Extra? Thank you. Okay, let's see. Dylan, did you come up with the 2 factors, hon?
Yeah.
Can you give them to me?
X equals 25 and x.
Oh, no, just give me the factors. Just the factors.
X plus 2 and x minus 25.
Someone confirm that for me?
I got x squared.
Ah, x squared. Is that factor all the way? It's not factor completely. What is that right there? Isn't that different two squares? So class, can I factor further if I have a difference of two squares? It should be x plus 5 times the quantity of x minus 5. That's factor completely. Okay. All right, so x plus 2 equals 0, x plus 5 equals to 0, x minus 5 equals to 0. So your 3 x-intercepts are these guys. Okay, let's plot them in. -2 is one of them. -5 is the next. And +5. Okay, I'm going to wait for a second so you can copy that down. Okay, so next we would like to find the end behavior, which will ask for degree. Guys, what's the degree? 3, good. What's an a value that we have? 1, okay. So if x approaches negative infinity, what's y approaching? What is it? Infinity. Do you guys agree? X approaches negative infinity. Y is approaching infinity? Isn't an x to the third, if I don't have a negative a value, I think I wrote it somewhere up here. Isn't the red one right here the parent function? Yes or no? So if x approaches negative infinity, what's y approaching? If x is approaching negative infinity, remember the red one is the parent function when a is positive. Negative infinity, right? So negative infinity. Yes or no? Then if x approaches infinity, what's y approaching for this odd function? Infinity. Okay. All right, let's negative infinity here, positive infinity there. Anything bouncing, was everything crossing? The 3 locations, are they all crossing? Or should it bounce at one of those or 2 of those? All 3? It bounces at 5? Does it? Okay, let's look at each one. At x equals to 2, what degree does this factor have? 1. So can we say right now it crosses? So at 2, it crosses. Next, at x plus 5, what degree does that one have? Also 1. Crosses or bounces? How about the last one? X minus 5. What degree does that one have? Also 1. So they should all be what? Crossing. So that one's crossing, this one's crossing, and that one's crossing. Okay, I'll take questions.